I've been kind of behind on that because
I love
they make you pay for episodes on demand.
I
Okay,
just watched it when I
so
was
we went with rational, algebraic, exponential, power, polynomial, and then trigonometry.
You did that for Bradley?
Yeah.
Hey, Bradley.
Recap for Bradley. Okay, then you want me to go where?
10.
But do you want me to go where?
12.
Do you mind if we go to 12 and come back to 10?
Yeah, that's fine.
Okay. Okay, 12. The manager of a weekend flea market, I wonder where that name came from, knows from past experience that if he charges X dollars for a rental space at the market, then the number Y of spaces he can rent is given by that fancy equation. Sketch a graph of this linear function.
I got the first part, I just don't have
Okay, the only thing I can tell you about this 200 minus 4x is that they want to give you this idea of this is where you start and then this is where you go. So the real question is, why do all the algebra books have it the other way around? You know what I mean? Because in a way it makes more sense. Go
Yeah, it
here
does,
and then do that. But I
That's how many-
understand it's
so
to
200
change.
is how many spaces you have.
What?
200 is how many spaces you have.
Is what? How many spaces do you have?
Never mind, just continue.
Okay, so you can graph that. B, what do the slope, the y-intercept, and the x-intercept of the graph represent? So what does the slope represent?
The more he charges, the fewer spaces he can have.
It's the number of spaces he loses per dollar.
Oh, okay.
So as he charges more money,
Oh,
a
yeah.
dollar more each time, then he'll lose, then 4 fewer people will want to rent a space.
I get it.
Okay, so
Okay, so for example, if he says spaces are free, how many spaces will he rent?
All of them.
All of them. But then if he says, I'm going to charge $1 for you to rent the space, how many spaces will you rent there?
196.
196.
I was gonna say 200.
Yeah, so there's going to be 4 people that'll be like, nope, $1, I'm out. Can't do it. The crap I'm selling is never going to make me $1, so that's a losing proposition. What does a y-intercept represent?
How many spaces you have?
How many spaces he
That
has
was my
total?
question, and
Okay.
then you were looking
Okay.
like I was crazy.
Because I didn't know what the problem was even asking.
how
Yeah,
do you
the
say
y,
slope?
the slope would be how many fewer spaces he will rent for each $1 increase in price.
Okay, yeah, that's like really long.
Yeah, but at the time that it takes us to have this conversation, you could have just had it written down. Okay, and then what does the x-intercept represent?
The minimum spaces he can have.
Minimum number?
Yeah, 0.
Oh, okay. Sure.
Why?
The y-intercept is how many spaces he has. He has 200 spaces.
And then the x-intercept is?
That would be if he rents 0, how much he would have to charge to rent no spaces.
Which is $50.
Yeah, so if he charged $50, then nobody would rent a space.
I thought X is the dollars.
It is.
For less space.
So to find the x-intercept, you set the thing equal to 0. And solving, you get x equals 50. So that means that if he charges $50, he will rent 0 spaces. So that's the x-intercept. And then the y-intercept is if he gave away for free, how many would he? How many spaces would he have altogether? That's a silly problem. Okay, so back to 10. Okay, 10. Recent studies indicate that the average surface temperature of the Earth has been rising steadily. Some scientists have modeled the temperature by the linear function. What do the slope and t-intercept represent?
Slope is rate.
Slope is what?
Rate of the rising.
Good. Slope is the rate of temperature rise. Surface, yeah, right. T-intercept?
Temperature rate.
Say again?
The temperature of the year 18.
Because that's when they started?
Yeah.
Okay. So the t-intercept would be what you would get when you plug in 0 for little t, and little t represents years since 1900. So that means the t-intercept is the temperature in 1900. All right. Use the equation to predict the average global surface temperature in 2010. What number do you plug in?
200.
200? Yeah. That's 200 years from 1900. So little t equals 200. So big T equals 0.02 times 200 plus 8.5 equals 12.5.
So,
Yes?
I was confused by this representation questions is, why do you have the t-intercept equaling temperature in 1900 when it's just temperature in general? At least that's what it says up there in the description.
Because the t-intercept represents one particular,
Okay.
so it can't just be like the temperature in general. The temperature in general is that formula. When they're asking what is the big T-intercept, what does that represent? They're saying if you plug in 0 for little t, what do you get for big T and y? Okay? Okay. So control board, 14.
Wait, I didn't know about 13. Oh, we can go back to that.
No, it's on our way. Okay, 13, relationship between, so Darius is what you and I were talking about, between Fahrenheit and Celsius temperature, sketch graph this function, nope. What is the slope of the graph and what does it represent?
Well, 9 fifths is the conversion factor, isn't it?
Yeah, so the increase in Fahrenheit for every degree increase.
Isn't that just a freezing point?
Yeah, so the f-intercept is what you get when you plug in 0 for the other variable. So if I plug in 0 for c, I get 32. So the f-intercept is equal to, I don't know what Celsius is at 0. So they're just saying when it's 0 degrees Celsius, that's 32 degrees Fahrenheit. That's what should be weird.
I think it's 32.
I don't know. And then 212 for the boiling point of water?
Yeah.
Our system is whack.
Yeah.
We're so stubborn. Never change. Okay, 14.
Yeah.
Yes. I don't know how to get this one.
It'd be great to change the metric here. It would create so many jobs. Everybody would, that people would have to go and change all of the highway signs, every single one, all of those mile markers would have to be
Oh my god.
everything.
That's why we can't change it.
No, we're in too deep. Okay, Jason puts on his hockey mask and leaves Detroit at 2 p.m. and drives at a constant speed west along I-96. Passes on Ann Arbor 40 miles from Detroit at 2:50 p.m. Express the distance traveled in terms of the time elapsed. So we know what's our favorite little old formula.
Distance n plus b.
What?
The dirt formula.
The dirt formula.
Not you.
Distance equals rate times time. So what is his rate?
It's the speed he's going.
Yeah, and so in this case, he went
40
miles in
50 minutes.
50 minutes. So that's 5/6 of an hour.
Yeah,
Right.
he goes 48 miles an hour.
Okay, so if you flip that over and multiply, yeah, you get 48 miles an hour. So his distance is equal to 48 t.
So then you have to draw the graph.
I've got to tell you that, okay, good. Yes.
But doesn't T have to be, yeah. So, never mind.
Okay, good talk. What's the slope?
Speed at which he moves.
So what is it?
48 miles.
48. And what does it represent?
His speed, miles per hour.
Yep.
What's the point of even drawing a graph? You don't use it.
Anything else?
What does the little T represent?
Time. In hours in this case.
Okay. Because we can.
Yeah. All right, so we continue to trudge onward, okay?
Trudge, like.
Trudge. That's kind of.
We made it to 1.3.
I think that's it.
Down Seahawks. Hey, we did 4 little review tests also. So this is
2,
really our
yeah.
7th section. All right, in this section, we start with the basic functions that we discussed in the last section and obtain new functions by shifting, stretching, and reflecting the graph. So this is that old left 5 and up 7 and vertical
So-
Well, I'm down for
stretches.
this.
Yeah, you guys have done this quite a bit. And then we're going to also do some math to combine the functions, which you're all good with except for the when you do f of g of x. That's a little bit dicey, but it's not too bad. Okay, so do you need to write this down? Probably not. If you add something to the graph, it goes up that far, right?
Yeah.
If you subtract something, it goes down. If you subtract something inside the parentheses, then it moves it to the right. And if you add something inside the parentheses,
See, look at how difficult they make that. Look how difficult they write that. They could just say y equals f of x plus c up. All you have to say, but that makes me not want to read it.
but then I would be out of job.
Why? You didn't
Because
write
then you can
that.
just read the book and figure it out yourself.
Like this is.
Exactly.
That's what makes it really confusing, so I'm here to translate.
That's stupid.
No, it's good. Otherwise, I'd have to like get a real job. Okay, then you can also stretch and reflect and whatnot. So if you take the function and you multiply the whole thing by a number, then that's a vertical stretch. Unless that number is less than 1, then it'll be a shrink. And then remember, everything inside the parentheses is always opposite. So if you multiply by something inside the parentheses, you would think that that's going to stretch it, but it's actually going to compress the
Okay,
graph.
compress, we're not using the word compress.
Okay, and then if you divide, same thing, you would think that dividing would shrink the graph, but since it's inside the parentheses, it has the opposite effect and it actually stretches. And then multiplying everything by a negative flips it over the x-axis, and putting in negative x instead of x flips it over the y-axis, okay? I'm not going to give you enough time to write all that down. You'll have to get it from your book if you want. Hey, look how prepared I am. I actually put like the graph paper up for this and everything. Bless you. Okay, so let's not even use the graph paper that I have here. Let's show this more clearly on a calculadora, okay? Where is it? Okay, so if we start with the graph of the square root of x, it's cool that you don't have to do like y equals on this. You just type in the thing and it just goes. You know what I'm saying? All right, then if I want to graph square root of x minus 2, what is that going to do to the graph?
It's gonna move it up 2.
Square root of x outside of the square root minus
But it was plus.
2. Then that's going to drop it down 2.
It was plus.
Right?
Maybe. That's the red one.
This one right
Yeah,
here.
no.
Okay. No, disagree. If I put the minus 2 inside the square root, what does that do to the graph?
Moves to the right.
Moves it to the right 2. Yeah? Everyone's a winner?
Yeah.
So were you guys the ones that asked me about the little circle thingies next to the table and what happens if you click on it, or is that a different?
Well, I mean, I
If you
asked,
click on this, it'll make the graph go away.
yeah, I asked about the other circle thing and you showed us that.
Okay. So that's kind of fun.
Good move.
Okay,
It's
then,
actually really handy on my phone.
it is?
Yeah.
Yeah.
Super
Yeah,
handy.
it seems like, you know, I'm down with this. Okay, then what about negative square root of x?
It's gonna flip over the x-axis.
It's gonna flip it over the x-axis. So, plus you don't have this like different negative and minus, it's just the same thing.
I know, that's really nice.
Yeah. Okay, so negative square root of x flips it over the x-axis. What's the next one? Oops.
And you don't have to click on the like stat and plot.
Right, it's
It
just
is
there, yeah. 2 times the square root of x does what?
Stretch.
Stretch of 2,
Yeah.
so 2 square root of x is the same thing, but it's a vertical stretch of 2. And then the last one, square root of negative x, what does that do to the
Flip over
graph?
the y-axis.
Flip it over the y-axis, yeah. So square root of, this time the negative is inside the square root instead of in front. It'll flip it
Looks
over
like a
the
bird.
y-axis.
I thought you meant square root.
It does. It looks like the old seagulls that you used to draw when you were in like 3rd grade, and you draw the house and the tree and the dog house and the clouds and the seagulls.
That's
Right?
spot on, yeah.
Do you remember that? Did everybody do that when they were kids?
I did.
Yeah.
Yeah, I did.
Okay, so there are some basic transformations. All right, what about x squared plus 6x plus 10? This is tricky. What we're going to do is we're going to go through how to graph this without just like plugging in points and without just plugging it into the calculator, just so you can sort of see what this is all about. And it relies on completing the square. So we put a little space in there. How do I complete the square here?
Take half of the middle column.
So it's not-
Half of this and square it, so that is 9. So I'm going to add 9 here.
I'm gonna add 9 to that.
No. I'm going to subtract 9 over there. Okay? Because plus 9 minus 9 cancel and give me 10, so I haven't changed the original problem. I'm just changing the form in which it is written. And the reason why I did that now is because this factors into x plus 3 and x plus 3, both plus. So that's x plus 3 squared. And that's for this piece right here. And then 9 or 10 minus 9 is 1. So this is going to be plus 1. So now you can see this is obviously going to be a parabola. You should have known that from the very beginning. How far is it going to be left or right?
It's gonna be up 3 and
Up 1, left 3. Okay, so we can confirm that by graphing. I can't remember what the.
Because 9, when you put it in the
Are you
square,
just gonna graph the
in the
original?
middle.
Yeah, I'm just going to graph the original so we can prove that we were right. And then what was it? Plus 6x plus 10.
And then you add it plus 10 to both.
Okay, so as promised, left 3, up 1. So that's what that completing the square process is for, is to get it into what's called vertex form, so you can see what the graph is going to look like. The only job that I can think of that would be better than teaching here is if I could teach at like a really big school and I could teach just calculus all day.
Why
Right?
would you want to keep teaching just calculus?
Because it's my favorite subject.
And then
You
you
guys
don't
are
get
all
then you, okay, well,
super nice kids.
then you don't get the people that just hate you because they hate math.
Right. Okay, these are a little bit trickier.
Okay,
Sine of
okay.
2x. Do you remember how to find the period of a sine function?
Yeah, you go from one point to the next.
Right, but from the function itself, from the equation, not from the graph, so that if I
I
have the
divided by
equation.
this,
Yeah, but divide what by that?
B.
2 pi over b.
Oh,
So
2
this
pi.
right here is b.
I said 5.
Okay, so the normal period of a sine or cosine function is 2 pi. But this 2 right here,
Pi.
again, it's a little bit counterintuitive because you're multiplying, so you think it's going to get stretched out, but it's essentially inside parentheses, so it's going to get shrunk. So the period of this is 2 pi over 2, which works out to be pi. Okay, so the graph of this would look like, I'm just going to go by 4s because pi over 4, pi over 2, 3 pi over 2, and whoops, oh, I screwed that up. What's supposed to come after pi over 2?
Wait.
This is half a pi, this is a whole pi.
Oh,
So
okay.
that is what?
3 pi over
3 pi over
4.
3/4 of a pi. Okay, and then the sine function, what do you know about it? It starts at 0, how far does it go up or down?
Goes up 1.
Up to 1, back to the middle, down to -1, back to the middle.
Beautiful.
Thanks. Talked to Coach Galloway a little bit after he came here because he used to teach in Olympia, and he said in Olympia there were kids that he had in class that he hated, like they were just
And so does the after school program. I have kids that.
That'd be hard. I wouldn't-
Yeah, no.
I'd find a different job. I don't.
You don't have anybody, not asking names, but you don't have anybody that just.
Not that I hate, not that I there's some kids that annoy me or that I wish paid better attention or, were smarter, but there's no kids that I'm like,
You didn't even
There
hate
was this-
Stephen Roberts?
There was
Who?
this
You
one.
didn't even hate Stephen when he was in your class?
yeah, he's not my favorite. That's true.
When I worked at the YMCA, one day I had 17 7th and 8th graders by myself.
Nice.
I think I about hit it all of them by the end of the day.
Yeah.
And then this guy had invisible ink and he kept spraying it on the girls and they kept freaking out. And I had to get
He
it from
had
him.
invisible.
Like you sprayed it and
That's
then you would spray it on
hilarious.
like a white thing and it'd be blue, but then it'd disappear. And then
Gosh.
and then I go, okay. Luckily, this guy, I could tell this guy was trouble, so I go, okay, give me the ink, and he gave it up too easy, and I go, okay, give me the other one, and then he gave that one up too easy, and I was like, give me the other one, and I think I got 4 out of it.
Nice. So you're a natural.
Yeah, I got 4 things out of him, and then
You
he was
figured
done,
it
and
out.
I was like, I know you got a whole bunch, just give it all.
More. Oh, wow, good for you. That's awesome. Okay, so here's the graph of the sine of 2x, and you can see that its period is pi right there. No, that's a different conversation. And then 1 minus sine x, what would that do? What's that going to look like?
Go down.
No, it's gonna flip
Flip it
it.
over.
It's going to flip it because this
And
is
it's gonna go
negative, so it's going to start going down instead, right? And then it's going to actually get shifted up 1 because the 1 is positive. So,
That makes sense.
what's that?
Let's just put it the other way around.
She's mad about the.
I think
The
that's
whole one
backwards
is
like
correct,
that because
yeah.
we've learned now, like you add it to this, we've learned that if it's a set egg, like if it's
Oh, that
plus 1, it
number
goes up
thing?
1.
You need counseling? Okay, so this would be shifted up 1. This point normally would be at the origin instead of up here. And then it's also flipped because you can see it starts by going down instead of going.
I think you're having ears and one's not.
Okay, figure 9 shows graphs of the number of hours of daylight as a function of the time of year at several latitudes. Given that Philadelphia is located at approximately 40 degrees latitude, find a function that models the length of daylight at Philadelphia.
It's kind of like,
So Philadelphia is this guy right here.
it's kind of like one of those things that like the lines intertwining, you have to follow the line.
Right.
You know what I'm talking about?
I do, kind of, yeah. So it's that guy right here.
And then they
Oh,
attach
really?
to something else and you have to figure out which one attaches to which.
Yeah, I do know what you're talking about.
They're looking at me like I'm crazy.
No, I know what you're talking about. I have some in my
Yeah.
drawer there, these little cards, and you have to.
Yeah, they attach to something over
Right,
here, but
which
you have to
one
figure out
goes
which
to
one
that,
attaches to
yeah.
it.
Yep, I know. Okay, so what function would you use to model this?
So cosine one?
Do you want to go cosine?
Yeah, so it looks like it's gonna go over down.
So this is essentially going to be our starting point?
Yeah.
Okay, so we need to know the period. hopefully this will ring maybe a little bit of a bell. We need to know the phase shift, which is how far it's shifted left or right. And we need to know the vertical shift.
Isn't the period like pi over 2b or something?
The period is 2 pi over b. Wait. Yeah, the period is 2 pi over b.
What does b stand for again?
B is the number that's in front of the variable. So when we figure out the period, we're going to use that to figure out what b is. And then that'll help us write the equation. Okay? So what is the period of this graph?
September.
If I go from here to here, how much of a period have I shown?
Half.
Half? Because
April to
up, down, and then back to there. So that is 1, 2, 3, 4, 5, 6 months.
So
So
it's
a
a
complete
year.
cycle would be a year, okay?
Which makes
So that means the period is equal to 12, okay? So 2 pi over b equals 12. So to figure out what b equals, I can do the old switcheroo and trade these two things places and say that means that b equals
Pi over 6.
2 pi over 12, right, which is pi over 6. Oh, there was one other thing, I knew there was 4 of them.
Oh.
Okay, so b is pi over 6, okay? A is the amplitude. So if this is the fancy word sinusoidal axis, how far above that does it go?
6.2.
6.2. I
I think
don't
you're wrong.
think so. This is 12. I feel like the high point is at about
Oh, that's
15.
the wrong one.
Okay, so how far above does it go? 3. So the amplitude is going to be 3.
Wait, I thought the
Okay?
amplitude was the entire,
No, it's the maximum minus the minimum divided by 2.
yeah, and that's not 3.
Maximum is,
18, and then the minimum.
Maximum is
Oh, I looked at the wrong one,
Oh,
sorry.
okay.
Okay.
Yep, that's all fine. Okay, how far to the right, we've decided to do cosine, so this is essentially our starting point. How far to the right is that spot? 1, 2, 3.7, love it. Okay, so that is the phase shift, that's, we're just gonna make that, say 3.7. And then how far above 0 is this, how far has it been moved
12.
up? 12. So that means that D is 12. So our equation is y equals 3 cosine pi over 6 times x minus 3.7 plus 12.
Wait, if it's cosine, isn't it moved up to where it's?
Yeah, that's why we had to start right here, because cosine starts at a maximum.
Yeah, so it's moved up 15.
Oh, no, because it's where how far is the middle of the graph,
Oh,
not the highest point of the graph. Okay? So, do you understand where all 4 of these numbers come from?
Why
It's
is,
the amplitude, period, how far it got moved to the right, and since that's inside parentheses, we have to use a negative, and then this is how far up the whole thing got shifted.
okay. So
I understand
the
what.
3 is the C.
3.7 is the C, that's called the phase shift.
So what's the 3 in front of the cosine?
That's the amplitude.
So my graph is will look the same.
Yeah, I was thinking about that. If you find a way to make the scale the same, then it should look the
And
same.
then
But the problem
after
is the
cosine-
butts on the bottom.
Yeah, but so if we make this be
1,
like,
2, 3.
yeah, 0, 1, 2,
I'm
3.
gonna try it.
Okay,
Is
let's give it a try.
is the phase shift how much it's bending upwards?
Oh wait, can you go back please? Thank you.
Mr. Aldridge, is
Yeah.
the phase shift?
How far it's gotten scooted left or right?
And it's gotten scooted 3.7.
Yeah, because we went, here's the high point. We decided to use cosine. If we'd have used sine, we would have started with this,
Yeah.
and then the phase shift would have only been 0.7.
I did not do that right.
So it's okay, so you're just using
Okay.
3 months.
Yeah, 3.7 months from, I don't know why they started in March.
Okay.
Let's make this graph. Okay, so it's 3 cosine pi over,
We have to go
6.
Woo! I'm sorry. No, not really. This scale is not the same.
And then it was X, what did we say, minus 3.7? Close parentheses, plus 12? Okay, and then our scale, we want that to be, the smallest thing on the x-axis was 0. And then we went, how many months did we go? Did we go 12 months? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 10. And then on the y-axis, the lowest was 0, and the highest was
20.
20.
That's
Okay. And there's our graph. And that, and that
Oh, that's right.
look roughly the same.
We should go follow them.
I should graph all of them. I
No.
should give you that as an assignment. Now come up with equations for the other. Good idea. Yeah. Okay. So there's only 1, 2, 3, 4.
If that'd be our only assignment, I'd do that.
Yeah.
Okay. How about the graph of the function x squared minus 1? Here's what I'm going to say for this. These are kind of a little bit fun.
It's gonna be the b, isn't it?
No, because the squared screws that up. So here's how you do this. You say, what does x squared minus 1 without the absolute value look like?
It's
Just a parabola down one.
Okay, a parabola down 1, and I'm going to make down 1 be a little bit more just so we can see what's going on, okay? So it would normally look like this, right?
Yes.
But absolute value takes all negative answers and makes them positive. So this little tiny piece here gets flipped up, doesn't go away. It takes all of these negative answers and turns them into positive. So instead of going down like that, it goes like that.
well, that's all.
Okay, yeah, it's cool because it's like it's just going along graphing, and then it gets to the x-axis. It's like, oh wait, I can't go negative, so then it has to turn around and go up.
But-
And then, oh wait, I can't go
So
negative.
basically, nothing can be below the x-axis.
Right, now it could be if I tacked on a minus like 7 there, because then I could take this whole graph and shift it down, right? But if it doesn't have that, then it's never going to go below the x-axis. So let's just confirm that also, because that could be crazy. X squared, what was it?
Minus
Minus 1? Okay, perfect.
It's a great graph.
There. Perfect. Okay, so it's normally would be a parabola that would go down like this, but then this little piece right there gets reflected back up above the x-axis. Okay, all right, we'll mess with composite functions tomorrow. And you work on some function transformations on your own, Jaden.
How would the back one look?
She's gonna roast.
Yeah, I know.
She's gonna serve that.
She won't do that. She just